a curve C has equation given. Question A shows that derivative of y is equal to this. So we can see that y looks like something of x in the numerator and something of x in the denominator. It's division of two functions. So to find the derivative, we should apply quotient rule. Formula is given in the data booklet, and it says that derivative is equal to denominator is denominator squared and numerator is numerator derivative. It's 4x plus 6 multiplied by just denominator x plus k minus just numerator 2x squared plus 6x minus 3 multiplied by denominator derivative, which is just 1. Notice that variable is x and k is just constant. And we need just expand it and simplify to get the required expression. So it becomes 4x squared plus 6x plus 4kx plus 6k minus 2x squared minus 6x plus 3 over x plus k squared, and it becomes 2x squared, 6x minus 6x is 0, plus 4kx plus 6k plus 3 over x plus k squared as required. The next, find the range of values of k for which a local maximum or minimum point exists. So when we want to find a local minimum or maximum, we consider what derivative to be equal to 0 and at least one point, minimum and maximum, to exist, there must be at least one solution. So we should consider derivative to be equal to 0, and we can see that it's a fraction to be equal to 0, and it's possible to be equal to 0 when numerator is equal to 0. Hence, we consider numerator to be equal to 0, 4kx plus 6k plus 3 should be equal to 0, and here there must be at least one solution. And we can see that it's it's quadratic equation with respect to x. K is just a parameter, it's a constant, and we should consider discriminant because number of solutions depends on discriminant. Discriminant is b squared minus 4ac, so it's 4k squared, 16k squared minus 4ac, so 4 times 2 times 6k plus 3, and at least one solution, so it must be greater or equal than 0. And we get another quadratic inequality. Let's simplify it, so it becomes 16k squared minus 8 times 6, it's 48k minus 24 should be greater or equal than 0. It's like another problem. It's a quadratic equation with respect to k now. K is a variable now because it's another problem, and we can solve it with aid of a parabola, of a graph of this function, and it's a concave up parabola because coefficient in front of k squared is positive, and we need roots. And if we know roots, and if two roots exist, we can see that values of this function to be greater than or equal than 0, solutions are here from this root to the left and from this to the right. And also we should take into account that k is positive. So let's find roots, and again you may use a calculator. I use just discriminant. Again, it's b squared minus 4 ray c. C is negative, so plus 48 squared, or actually, yeah, it's correct, but actually when we find roots, we consider it just equals to 0, and we can divide each term by some value, and we can simplify it to divide by 8 to get 2k squared minus 6k minus 3, and is 0. Definitely it we can solve directly this, it doesn't matter, but it will be much simpler. So discriminant is b squared 36 minus 4 ray c plus 24, it's 60. Then roots are minus b, 6 plus minus root of 60 over 2a over 4. And it seems that this is negative, but k is positive, so the first root is 6 minus square root of 60 and divided by 4. It's some negative value, and we don't need this value at all. Let's write it's minus 0.434 436 to 3 significant figures. And another root is 1 plus and it's 3.44. And in general, a solution is from negative infinity to this point, including, and from 3.44 including to plus infinity. But here k is positive. K is positive. So finally, since k is positive, a solution is k is greater or equal than 3.44, because we consider greater or equal than 0. The next, consider the case 1, case 2. Question C, write down the equation, the vertical asymptote. Vertical asymptote arises only if there is division by 0, and if case 2, we can see that x is negative 2. The next, write down the equation of the oblique asymptote. Let's rewrite, substituting 2 for k into our function y to get y is 2x squared plus 6x minus 3 over x plus 2. And there are a few methods how to find the oblique asymptote. I want to use the next, that the oblique asymptote, it's just it has just an equation of a straight line mx plus c, and gradient m can be found as limit when x tends to infinity function divided by x, and it's quite clear that it's 2. It arises from this, and it becomes limit function divided by x. It becomes 2x squared plus 6x minus 3 divided by x squared plus 2x, and limit when x is very large, we take into account only the greatest powers of x, because other terms will be much smaller, and we can see that it acts like 2x squared over x squared cancels, and it's clear that this limit is 2. M is found. And how to find C? C can be found using the next formula. Its limit when x tends to infinity function minus mx, and it becomes limit our function 2x squared plus 6x minus 3 over x plus 2 minus mx. M is 2, it's a found value, found gradient, it's minus 2x, and it becomes limit, just common denominator, minus 2x squared minus 4x. And we can see that 2x squared cancels, and we get that its limit 6x minus 4x, it's 2x minus 3 over x plus 2. And again, take into account only the greatest powers of x, and it acts like 2x over x cancels it, and limit is 2. So equation of the oblique asymptote is 2x plus 2. The next shows that dy by dx is greater than 2 for all values of x. And for such type of questions, it's more useful to consider this left-hand side minus the right-hand side, and then to compare, and then we just compare with 0. So let's consider dy over dx minus 2, and when it shows that it's greater than 0, so we just rewrite dy over dx, substituting 2 for k, and it's 2x squared plus 8x plus 15 over x plus 2 squared and minus 2. It becomes, and again let's make a common denominator, x plus 2 squared, and it becomes 2x squared plus 8x plus 15 minus 2 and x squared plus 4x plus 4, which is 2x squared plus 8x plus 15 minus 2x squared minus 8x minus 8 over x plus 2 squared, and we can see that it becomes 7 over x plus 2 squared, and it's clear that it's it's greater than 0, and hence dy over dx is greater than 2 as required. The next, sketch the curve, and xy intercepts are not required here. And from the previous questions, what does it mean when derivative is greater than 2 always for all x, it means what the derivative is positive, and positive derivative implies what that function is increasing. So everywhere function is increasing, and there is vertical asymptote at x is -2, and also there is the oblique asymptote. So this curve looks like this. Why? Like the vertical asymptote through x is -2, and its x is -2. Then oblique asymptote is what? 2x plus 2. It's through 0, 2, and the gradient is 2. So something like this, and its y is 2x plus 2, and function is always increasing, and it tends or falls on this asymptote when x increases, and falls on this vertical here, so it looks like this. And also here falls here and falls here, and so that it's always increasing. Definitely you may use a calculator, just plot a graph. XY intercepts are not required here, so it looks like this, but definitely it can be easily deduced how to plot it without a calculator. And that's all for this question.